Hello everybody, welcome to this series of videos on statistics. So first, what is statistics and why do we do statistics? I mean, in statistics we generally collect data, we organize the data properly so that we can do some analysis, presentation, etc. And analysis is more, it could be graphical or numerical. So we do all this with the data, right? And why do we do that, and for what do we do that? And we do all this to draw conclusions based on our data, right? So in this session we're going to look into semantics or terminologies. So mostly we're going to look into terminologies related to data and how to collect and organize data. That's what we're going to do in this session. So first, let's look at this set of data. Here are the name of the students or name of children or people. Now these are, we call it as individuals. Literally, an individual is not just a person, but it could also be some noun, something about which we have collected the information. And these are the information that we have gathered here. These are called our variables, right? These are variables. And if you see these variables, we have three different kinds of variables here. The one is this is called continuous variable. Oh, sorry, these are discrete variables. Really sorry about that. These are discrete. Now when we say discrete, what do we mean by discrete? It can take only specific values, right? You cannot have a shoes of size 7.25. This is not possible. You can take only 7, 7.5 and so on. So you can't have any arbitrary values. Now these types of variables like height, weight are called continuous variable. Continuous variable. Now other examples can be temperature or humidity or something like that. So the idea of continuous variable is it can take any values. So there is no discrete, its values are not discrete. It can take any value. And this is also, gender is also a type of continuous, it is not. Gender can be looked at as a discrete variable, but there is a name that we give for the discrete variable. This is called categorical value, right? Or categorical variable. So it's a category here, right? So it can either be a boy or a girl. So that's a category. So these are also discrete in some ways, or this is actually discrete. The categorical variable is type of discrete variable. So these are the different types of variables. Now this data which we have represented, this we can call it as raw data. So this is just a raw data. Now we can visualize this data in a little different way. If we can sort all this information that we have, the shoe size, height, weight, gender and all, then we can derive some meaning out of it. So let's see how this data looks after sorting. Here you go. So these are called array data, or you can say sorted data, right? So these are sorted either in ascending or descending order. Now once we do that, if you want to derive more meaning out of this data, maybe we want to find out how many people are with different shoe sizes, right? And how many people are there with certain range of height or certain range of weight. So for such kind of analysis, we do something called frequency distribution. So it's called frequency distribution. So let's take the previous data and let's take this data set and see how we can do the frequency distribution. Now, to do frequency distribution, by the way, a frequency distribution is nothing but here we are trying to find number of items of grouped or ungrouped variable. So yeah, we know what variable means. Those are shoe sizes, height, weight, etc. Now, what do you mean by grouping or ungrouping? So let's first look at the ungrouped variable. So this is ungrouped variable frequency distribution, right? If I were to group this would look a little different. So maybe a grouped variable would, for let's say height, would look like this. So let's write the grouped variable for height will look like this. Here you can see that we have grouped the height from 100 to 120 and 120 to 140, 140 to 160, 160 to 180, etc. Right? So here we have grouped them like this. So how do you find out the frequency distribution? So for that we use a method called the tally method. So here what we do is, hey, let's go through this whole data. So the first person is 5, so we say, okay, we put one tally. The second person is 5.5, another tally. Third person is 6, one more tally. 6.5, one tally. 7 and 7, so this has 2 tally. 7.5 has 1 tally. 8 has got 2 tally. And 9 is 1 tally, right? So even if this were not arranged, you can still use your tally for big data sets using this method, right? So here it's quite simple. It's 1 1 1, 2 1 2 1. Now let's try one more ungrouped variable, which is without this kind of grouping. So let's take this gender. So gender can be boy or girl. So let's draw the frequency distribution for that using our tally method. So here you see boy or girl. So as I go through this row, oh, this is not sorted here. Yeah, this one is not really sorted, unlike other sets. So let's see how to do the tally. So you have the first one is a girl, the second one is a girl, third one girl, fourth one is also a girl. And here for boy, 1 2 3 4 5 6. Oh, it's sorted, so not a problem. So there are 6 boys. So usually in tally method we count till 5. 1 2 3 4 and put a cross. So that's 5. So 5 boys. 1 2 3 4 5. So for that I have 5 lines. Now one more boy. So I put one more extra line. So it just, you can keep on doing this. So here we have 6 boys and then 4 girls. So that's how we use the tally method. Now for a group variable, let's try to do the same. So here we have grouped these variables between 100, 120, 120, 140, and so on. One important thing is you see that the 120 comes here and here. So generally it's important to keep in mind that the upper bound is usually excluded if there is a clash. So this is excluded. So there's a name also we give. we call this as exclusive class interval. So that's what this name we give. So we exclude this 120, right? And these are called the class interval, or in short this is written as CI. And let's do the tally for this class intervals. So 120 will not go into the first one because it's excluding 120, so we go in the second one. 125 second one, 130 second class interval, 134 second class interval, 140 it doesn't go into this, it goes into the next one. 145, 150, 156, 160. Again 160 goes into the next one. So you have 160 and 175. So your frequency is 0, 4, 4 and 2. So these are our frequencies. Now there are two more terminologies for this, or couple of more terminologies for this class interval. Within this class interval, when you look at it, we can say, hey, what is a class size? So a class size is equal to upper minus lower limit. And here you can see that the class size for each of the class would be upper limit is 120 and lower limit is 100. So so for example, it is for the class interval 100 to 120, the class size is equal to 120 minus 100. So that's equal to 20. So that's your class size. So that's important to know what do you mean by class size, right? So I'm marking all the terminologies that we have introduced here: ungrouped variable and grouped variable, class interval, class size. Apart from class size, you can also define the class mark, which is somewhere the mid value of this class interval. So I can say, hey, the class mark for 100, class interval 100 to 120 would be equal to 100 plus 120 divided by 2. That is equal to 110. So that will be our class mark. Oh, sorry. Yes, that's 110. That's 2. Oh no, that's wrong. It is 100 plus 120 is 220 by 2. Yes, that's right, 110. Similarly, between 120 and 140 will be 130. So that's exactly the half point of the class interval. Now let's look at one more example. In this example, we have the marks of children in a class, and these marks are given as 0 to 9, 7, 10 to 19, 7, and so on. So between these marks there are so many children. That's what we mean here. So you will straight away see that there is something different from the previous example where we saw an exclusive class interval, which means we excluded the upper bound. Here we don't have that luxury because this 9 and 10 are different. So what we do is we have to include all of this. So in each of the class interval, all the n boundary values are included. How do we know that those are included? Straight away by looking. If this 9 and 10 are different, then we can say that the previous class interval, the upper limit was included. So when you get a data like this, it's a little tricky. So you would want to convert this this kind of class interval data, we call it as inclusive class interval. So we would like to do something about this inclusive class interval data set, and we would like to make it into an exclusive. So the way we can do is, instead of 9 and 10, we can go somewhere in the middle, and we can say, hey, this is 9.5, this guy starts at 9.5, and this data starts from, instead of 20, somewhere between 19 and 20, which is 19.5, and go and keep going. So 29.5, 39.5, and 49.5. And the lower bound would be, the same thing here, 49.5, and here this would be 39.5, and this would be 29.5 and 19.5. For the previous data set, we can write this as 9.5, and this would be minus of 0.5, because you can see that'll make it consistent across all the data sets. And this would be minus 59.5. So what we have done is we have made this non-continuous or inclusive class interval into so-called exclusive class interval. So this has become now exclusive class interval. Now, once we convert this into an exclusive class interval like this, we can do one more interesting analysis. So if you want to find all marks less than a particular value, like less than 9.5, 19.5, so let's say less than 9.5 would be 7, because we know that now 9.5 is not included in this 7, right? Because we don't include the upper limit when it is an exclusive class interval, right? So this is not included. Okay, so when we want to find less than 9.5 is 7, and less than 19.5 would be 7 plus 7, and that's equal to 14. Less than 29.5 would be 7 plus 7 plus 12, which is 14 plus 12, and that would be 26. Less than 39.5 would be 26 plus 15, that's 41. Less than 49.5 would be 41 plus 10, that's 51. Less than 59.5 would be 51 plus 6, that is 57. So these are called the cumulative frequency. Cumulative frequency of our data set. All we need to do is to keep adding and get your cumulative frequency. The meaning of that is, it represents the number of values less than the upper limit of that class interval. That's what that means. So here is a summary of what we have done so far. So we have taken raw data, and in raw data you have the individuals and you have the variables, and variable can be represented as frequency distribution, and there are two kinds of frequency distribution. One is ungrouped variable. We don't group the variables, and we just try to, using the tally method, find the frequency. And then you have group variable, and in a group variable you group the variables into certain ranges, and these ranges are called class interval. They are called the class intervals, and there are two types. One is the exclusive, wherein you exclude the upper limit, so all these upper limits are excluded. And then you have the inclusive, where all the upper limits are included. So you can convert an exclusive class interval to an inclusive class interval by finding out what is in between the upper limit and the lower limit. So you can based on that you can find out what is an inclusive class interval. Inclusive means that you include the upper limit here. And other concepts we looked into are cumulative frequency, class size, and class mark. From this video onwards, we are introducing a new idea, which is basically to have a checkpoint at the end. And here is your checkpoint question. You need to find, for this class interval which is inclusive, you need to find the exclusive limits, the class size, class mark, and the cumulative frequency. So try to update the comments with your answers, and any questions you may have. You may want to go back and check the video again. You should be able to answer this checkpoint question with what you have heard in this video. So I hope you enjoyed this. See you in the next one. Bye.